Hi everyone, welcome back to the MyTutor online school for today's live group tutorial on solving quadratic equations part 2. If you're joining us for the first time, the session will be led by one of our star tutors, Molly, who is a student at Bath University and has done over 150 lessons with MyTutor. So the plan for today's session is a quick recap of what we covered yesterday, because there were lots of bits that people wanted answers to: factorising with greater coefficients, solving equations after hard factorisation, completing the square, and then for the last 15 minutes we'll have some time for some questions. I'm just going to hand over to Molly now.
Hi guys, I'm Molly, for those who weren't here yesterday. And yeah, as Frederica said, I'm going to be taking this lesson, which is kind of a follow-on from yesterday, basically with some slightly harder questions, and then doing some completing the square as well, because I know that quite a few people were keen for that. So hopefully I can share my screen. So you should all be able to see the lesson space. So we'll jump straight in with just a quick recap from yesterday. So basically about how to solve basic quadratic equations and what those are. So if we have something like 3x squared equals 48, and then we want to make that left-hand side of the equation just equal to x squared. So to do this, we divide by 3. So x squared equals 16, dividing both sides by 3 here. And then the key thing, basically the main point of why I'm showing you this, is that there are 2 solutions to quadratic equations normally. Sometimes the 2 solutions are the same if you have something like x minus 3 all squared or something, so your solutions are 3 and 3. But in this case, the solutions are plus and minus 4, because 4 squared is 16 and minus 4 squared is also 16. So hopefully that makes sense. By the way, feel free if I make a mistake or something needs a bit of clarifying, message on the chat. And also whack on some bigger questions if you want, and we can come back to them at the end. Cool. So then we did some questions that involved some factorization. So for example, x squared minus 15x plus 56 equals 0. So the key thing is that we always want our quadratic equation to equal 0, because then we can work with it. And you'll see why in a moment. So the reason is because when 2 things multiply to equal 0, one of them has to be 0. Like I said, you'll see. So to factorize, we set up our brackets. So here we just have a single x squared. Now, in a bit, we're going to be doing ones that are a bit harder, because you might have a 2x squared or something here. But when it's a single x squared, it's just x and x. And then we have to decide what signs go in here. So are they pluses, minuses, one of each? And the way that we can tell that is that this 56 on the end, so this is what these 2 numbers multiply to be. So they have to be either 2 pluses or 2 minuses. That's the only way that you can make a positive. Positive times a positive is a positive, and a negative times a negative is a positive. And the way that we tell whether it's plus plus or minus minus is because of this. Now, because this is subtracted, we know that it has to be a minus and a minus. So that's how you set it up. And then we want something that multiplies to make this and adds to make this, because that's what happens when we multiply out the brackets. So what I always do is list our factors of this number here. So 56, so it can be 1 times 56, or 2 times 28, or 4 times 14. This is where I hope I don't make a mistake. Or 7 times 8. I think that's all of them. So then we want to choose which pair we're going to use, and they're going to be the ones that add to make 15. So we can just have a quick little look here. This makes 57. This makes 30. This makes 18. 7 and 8 make 15. So those are the numbers that we're going to whack in here. So we have x minus 7, x minus 8. That's how we factorize that. And then to find our solutions, well, one solution is when this bracket equals 0. So x equals 7, for that one to be 0. And the other solution is when this bracket equals 0. So x equals 8. So those are our two solutions. Either x is 0 or x is 8, and this equation works. Hopefully all of that makes sense. So now we're going to go on to some ones with greater coefficients. So ones that are, these ones can be a bit trickier, but it's the same process, just a bit more trial and error, a bit more thinking with it as well. So let's have a go at one that looks like this. 2x squared plus 7x plus 3. So I know that that first bit was quite quick because it was just a recap. I'll do the pace a bit slower now. So the first thing that we want to do here is set up the brackets. So we know because it's a squared, it's just 2 brackets. Now, the first thing that we have to think about is how are we going to get this 2x squared? Well, when it's x squared, it's by doing x times x. When it's 2x squared, the only way that we can make that is by doing 2x times x. So that's going to be what goes at the beginning of our brackets. Hopefully that makes sense. That's how you get that term. Now we'll think about the signs again. It's always the same process. Brackets, x's, signs, numbers. I was wondering if there was some sort of thing to remember that mnemonic, but maybe not. So now we look at what signs we want. Now we always start by looking at this. Because it's added, we know that it either has to be 2 pluses or 2 minuses, same as the previous example. And because this one here is added, we know that it has to be 2 pluses. So we can whack those in. Awesome. Now all we have to do is fill in the numbers. We've done a lot of the hard work. So we're going to do what we always do and start by listing what multiplies to make 3. Now the only thing is 1 times 3. So this is a good case to be in because we only really have 2 options. We either put the 1 and the 3 this way or do it 3 and 1. So if you want, you can just try both, expand them and see what you get. That's essentially what we're going to do, but kind of in our heads. So we know that if we put the 3 here, it's going to be multiplied by the x. And that's because of the way when we do the FOIL method or the grid method, when we expand, this one is multiplied by this one is multiplied by this one. So it's those kind of inner and outer ones. So that means that if we were to put the 3 here and the 1 here, we'd get 3x plus 1 times 2x. Maybe I'll write this one out because I'm aware that I'm just saying a lot of words and you might wash over you. So I'm going to write it in grey because it's an option. We're not saying that it's right. We're just testing it out. Ooh, wrong way. I'll put 3 there. So we know that we're going to get 2x squared. And we know that we're going to get a plus 3 on the end. That's why we've chosen these numbers. What we're trying to do now is make that middle bit work. So here we get this term giving us a plus 3x. And this term giving us a plus 2x. Because it's 3 times x and 1 times 2x. Hopefully that makes sense. It's difficult because you've got to keep track of the coefficient of the x, so the number before the x, as well as the number that's there. So then this gives us 5x, which is not what we want. So, I mean, because there's only 2 options, we know now that it's the other way, which is good for us. So that means that the 1 goes here and the 3 goes here. And we can do a quick check. 1 times x and 3 times 2x. 1 plus 6, 7x. So this is the answer that we want. Hopefully that made sense. Shout in the chat if it doesn't. I can't see anything in the chat. I hope that that's because you're not talking rather than that it's broken for me. But we'll just do another example. I think the best way is just to see loads and loads of examples and we'll get the hang of it. So let's have a look at this. 5x squared plus 28x plus 15. Let's have a go at factorising this one. So I'll try to leave pauses in between so that if you're trying to work it out as well. There we go. So the first step is the brackets. And now we need to think about what's going to go at the beginning of these brackets. So that's going to be 5x and x. because that's the only way that you can get 5x squared. There's nothing else that we can do. It's kind of similar. We're kind of working out what can multiply this. The only thing is 1 and 5, so that's what we stick in front of the x's. That's kind of what we're doing here. Then we work out the signs. So that's going to be plus and plus. And so it's the same kind of situation as before. This is added, so the signs are the same. This is plus, so that's what the signs are. Now we just need to do the numbers. So we list what we can multiply to make 15. And it's 1 and 15, 3 and 5. And now we want to work out how we can put these numbers in. So the way that I do it is kind of try almost everything and work out. So we can try like 1 and 15, 15 and 1, 3 and 5, 5 and 3. The way, I think once you get used to this, you can start to be able to see it. For example, if we put 15 here and times it by the 5, it's going to be way too big. We don't even need to know what 15 times 5 is to know it's going to be way bigger than the 28 that we want. If we put the 1 here and the 15 here, we get 15 times x, 1 times 5x, which is 20x, which is too small. So we know that it's not this option. We've tried those both ways around and it doesn't work. So it's going to be 3 and 5. If we put the 3 here and the 5 here, we get plus 15x. So 3 times 5x plus 15x plus 5x. So that's plus 20x again, not right. If we put the 5 here, we get 25x, and then the 3 here, add the 3x to give us 28x. So that's kind of, it's a really difficult one to explain because it is quite a lot of trial and error. The key thing to remember is just to, not drop your pen. Once you've worked out what the x's and the signs are, you just list the factors of the constant on the end. So list what multiplies to make this and just try them. These questions are going to take a while just because you do have to try a lot of options. But the more you do, the better you'll get at trying them all in your head really quickly. So kind of immediately seeing that 15 can't go there and so on. So we'll have a go at one more, just because I know this is a tricky one. And then we'll have a go at some where we then solve an equation with it. It's only a tiny little extra step, but it's worth having a go at. So 3x squared minus 11x plus 6. So we're going to set up our brackets. Shock horror. And then we need to work out what goes here. So we think, we look at this side, well, it's only can be 1 and 3. So it's going to be a 1x and a 3x. I always put the bigger one here. You don't have to do that. It doesn't matter. The key thing that matters is that the things inside the brackets are right. So the right signs go with the right ones and the right numbers. Hopefully that makes sense. We'll see an example in a bit where the signs, actually, yeah, I'll include an example where the signs are going to be the other way around. We did one like that yesterday. So then you have even more trial and error, basically. All good fun. So now we want to know what signs to put in. Excuse me. So this one is positive. So we know they have to be the same. So either plus plus or minus minus. And then this one is negative. So they're going to have to both be negative. Nice and easy. Then we list the things that multiply to make 6. So we have 1 and 6, and 2 and 3. And then we try these basically. So again, there's 4 things to try. We can immediately rule some out. If we put 6 here, we know that that's not going to work because this will make 18. That's too big. If we put 1 here, we get 3 and 6. Hopefully you can see that because we put a 1 here, so it'd be 1 times 3, and a 6 here, so it'd be 6 times 1. That makes 9. That's not right. 2 and 3. If we put the 2 here, we get 2 times 3 is 6. 3 times 1 is 3. So you'd get 9 again, so that's not what we want. Whereas if we put the 2 here and the 3 here, we get 2 times 1, and 3 times 3, which is 9, which gives us the 11 that we want. So you can test this. I'll kind of prove this one to you by expanding it out again. So 3x squared, because of these two terms. Then we look at the outer two terms, so this gives us minus 9x. Then we look at the inner two, minus 2x. And then the last two, minus 2 times minus 3 is plus 6. And you'll see that just by combining those x terms, we get minus 11x. So that's just kind of a proof to you that this works. Cool. Now let's have a look at when these things are in equations. So in doing this, we're also going to have a look at another slightly tricky example. So 4x squared plus 19x plus 12 equals 0. So it's in our equals 0 form. Lovely. That means we can go ahead and factorize this, and then we'll be able to solve it because that's equal to 0. So there's no rearranging to do first. We'll just jump straight in. Now, the tricky thing about this factorization is this 4. And I'll give you a moment to try to spot why whilst I'm... If anyone wants to say why they think it's tricky. I don't know if the chat's working or not. I've just no one's talking, as I said. But
Hey, Molly.
Hello.
Is
it working?
Yeah, I'm just taking questions as they come in, and I'll flag some.
Oh, lovely.
As well.
Perfect. Thank you.
No
cool. So the reason that this one is tricky is because with the others, there was only one way that you could make it. So there was only one way of making 3, 1 times 3. But 4, we can have 1 times 4 or 2 times 2. So this means that our brackets could either, I'll just kind of write them underneath here as 2 options. They could either look like 4x and x or 2x and 2x. So suddenly it's become a bit more difficult because we've got more options to try. But that's okay. We just won't write, we'll keep them in grey underneath so that they're there and that we know they exist. And we'll just try like we did before. Now this one's even trickier because 12 has quite a lot of factors. So we've got 1 times 12, 2 times 6, 3 times 4. Yeah, that's what there is. So now we've got 2 different brackets and then 3 different pairs that could each go 2 ways. So you've got, oh gosh, 1, 2, 3, 4, 5, 6, 12 different options to try. So here's where it comes in quite useful to be able to eliminate certain options. So first of all, we know that if we put 12 in here, then it will give us 24, and that's too big. So we know that this pair can't go in this one. Now we know that if 12 goes in here, this will give us 48, too big, so it can't be that one. So we'll try it this way. If 12 goes here, then we get 12 plus 4, 16, so that's not right. So we can eliminate that pair. So yeah, I know I did that quite quickly, but hopefully you can kind of see how that works with this. Okay, now let's have a look. You can be quite sneaky with these sometimes. So 19 is odd. So it can't just be the sum of 2 even things. If we put 2 times 6 in either of these, it's going to be the sum of 2 even things. Hopefully that makes sense. Obviously, you don't have to spot all of these tricks. I'm saying you can just try all 12 options. No one's going to stop you. That's fine. These are just ways to make it a little bit quicker for you. So, you know, if we put 2 in here, we get 2 and 24. You know, no way that we try it. So that means that we don't even have to try 2 and 6 because we know that we can't get 19. Hopefully that makes sense. That's a bit more of a subtle one. Just shout if you want me to come back to it. So that means we know what our numbers are. Our numbers are fantastic. We know that they're 3 and 4. So we know that it either has to be kind of 3, 4, 4, 3, or 3, 4. Well, we only have to try 1 in here actually, don't we? Because they're both 2x. So we know we only have to try 3 things. 3, 4, 4, 3, and 3, 4. So yeah, so we can just go ahead and try those basically. So let's try it in this top one. If we put 3 here, we get 12 and 4, which is, oh, that's the other thing as well, actually, just if we wanted to make it a little bit quicker, sorry. If we were to put 3 in this one, it would be times a 2x. You can almost kind of eliminate these, you can eliminate these brackets for the same reasons that you're never going to get 19, because you're timesing them both by 2, so they're going to all be even. Don't worry if you're not following everything that I'm saying. Like I said, no one's going to stop you from just trying everything. But yeah, we can eliminate those brackets as well. So you can be sneaky with these is what I'm saying. And yeah, as I said, if we put 3 here and 4 here, then it gives us 16, which is not what we want. So we've worked out what our solution is. It's going to be 4x plus 3x plus 4. That's 4x squared plus 3x plus 16x plus 19x, fantastic, plus 12x. So this is the equation that we end up with. So that's kind of the trickiest that factorization is going to get, when you've got multiple options for both how to set up the brackets and what to put in the brackets. So it's tricky. So well done if you followed that, or even if you followed part of that. Well done. So now all that's left to do is to solve this equation. So hopefully if you were here yesterday, you remember from then that one of these brackets needs to be 0. So if it's something a bit trickier like this, that's going to equal 0, we can just write it out and work it through. So 4x plus 3 equals 0. And then we'll take 3 from both sides. And then we'll divide by 4. So minus 3/4. And then this one is a bit easier. I'll still write it out just in case you can't immediately see it. X plus 4 equals 0. All we have to do to this is take that 4 to the other side. So now I'll write it down here. This screen is a mass of colour at the moment, so I'll make it clear. X equals minus 3/4, or X equals minus 4. Those are our solutions to that horrible looking equation.
Hey Molly, we have a few questions coming through.
Sure.
So people want to know how you got the 19x.
That was just part of the that's just what the question was.
Okay, cool.
Yeah.
And someone else has said, can we do exam style questions?
Yes, sure. Yeah, I've actually got a couple lined up that are slightly more exam style, but I can always look them up as well. So I'll add them. Was that everything? I'm guessing so.
Yeah, that's everything.
Cool. Yeah, so there's some more like wordy questions coming up, but also I'll grab some exam style ones as well, actually. Let me see what time I'm on. Yeah, cool. I'll go through one of those now for you. So, yeah, okay. So this is one where, okay, this is difficult with me in the way. I'm just going to screenshot this for you. So this is one, I suppose this is not quite exam style. I suppose this is more of a kind of maths challengey type one, but we'll come on to exam ones, don't worry. This is one basically where you have to form the equation yourself. So Ben opened his history book and noticed that the product of the 2 pages in front of him was equal to 1,122. What were the numbers of those pages? So this question, I always find word questions like throw me off a bit, because you can't really see many numbers. You can't see the maths that you have to do, and that's because you have to form it yourself, which is the trickiest part of this. So if we imagine, basically all he's doing is his book. Wow, I should be an artist. And there's 2 numbers down here, and when you times them together, it equals 1,122. That's all this is saying. So what we have to do is just call them something. So for example, let's call this page X, because we like X, we use it a lot. Whatever that page number is X, which hopefully, if you've read a book before, you'll know that this one has to be X plus 1, right? 1 higher. If this was page 10, the next one would have to be page 11. If it was page 77, the next page would have to be 78. and we just represent that as x plus 1 more than the page before it. Now we can just write the product of that. So x, lots of x plus 1. This just means x times x plus 1. So those two numbers multiplied. And what we know is that that's equal to 1,122. And now suddenly this looks like something we're kind of a bit more familiar with. We've got some x's, we've got some numbers, we're happy. So now we'll kind of work through this. So we'll start by expanding out. We can see that because we've got an x times x, it's going to be quadratic. So we know that we want to rearrange so that it's equal to 0. So we'll multiply this out, x squared plus x. X squared plus x equals 1,122. And then we'll just take that number to the other side so that it equals 0. X squared plus x minus 1,122 equals 0. Lovely. Now all we have to do is factorize and we're done. Now it's horrible to factorize because who knows what the factors of 1,122 are? Nobody. If you know the factors, that's impressive or weird. So this is a bit of a difficult one. This would be most likely on a calculator paper because we're going to have to work out what these factors are. We can, however, do most of the work using the techniques that we know. So we can set up the brackets. It's just an x squared, lovely, so we just put the x's in. And this is negative, so we know that we're going to have 1 plus and 1 minus. And now here's another bit where we can be a bit sneaky, like we were with the previous one. So because our x term here is just an x, that just means it's 1. So that means that the things that we multiply have to have a difference of 1, so that when you add one and take away the other, you're left with just 1x. Hopefully that works. So say if it was, I'll just pop it in a different color. Say if this was like 8 and 7, you'd get minus 56, not the number that we actually want, but you would get plus x. So that's what we're looking for. Two numbers that multiply to make 1,122 that are one number apart. Now, when I did this question earlier, I did it on my calculator, just using trial and error. You can work out roughly where it's going to be. You know, it's going to be kind of around the 30 mark, because 30 times, say, 31, it's going to be 930. You can kind of guess these things. That's not what today is about, so I won't go through that. I will just tell you that what you will get is 33 and 34. And now the way round that we put these, well, we want the 34 here, so that we get 34x minus 33x, because this is a positive x, basically. Which means that the solutions to our equation, remember, are where one of these things equals 0. So either x equals minus 34 or x equals 33. Hopefully you can see where I've got those from now. This one here and this one here. And at the end of last time, we went over a trapezium question. And I said that sometimes you have to just choose one of the solutions. And with the trapezium one, it was because you took the positive answer because you can't have a negative length. Here, we're going to take the positive solution because we can't have a negative page number. It would be a bit weird if he started on page minus 34. You know, he could be, but I doubt he is. So that means that this page is 33, which makes this page 34. So the numbers of those pages are 33 and 34. Hopefully that will make sense. Don't worry too much about how I found the factors of this number. The main thing to see here was how we formed our equation. How we took this, decided to call it x. So this had to be x plus 1 and formed it. So this is much more in the style of an exam question, because especially a later one, kind of a horrible wordy question, basically. So I should be able to just have a quick look for another exam style question. Oh gosh, I did something. Did I stop sharing? I did. Well done, Molly.
That's okay, Molly.
I'm just trying to find an exam question. Oh, I clicked stop share instead of new tab. That went well. Oh my gosh.
I did it now, so it's fine.
Okay.
I'll put it back up once you found the question.
Oh, okay, perfect. Thank you.
No worries.
Meanwhile, if anybody has anything else that they want me to go over now that I can find, go for it. Quadratic equations, exam questions. Cool. Hopefully this happens quickly. Yes, it has. And hopefully these questions are good questions that we like. Okay, fantastic. Let me find a good one. Okay, let's go for this. Okay.
If you have a go at sharing again now, see if it works.
This time. Share screen. Share. Lovely stuff. Right. Write this question on here. So this is, as you'll notice, much more of an exam style question. A ball is thrown vertically upwards from a point P. Oh God, it already feels like an exam hall, doesn't it? God. The height above P of the ball t seconds after it was thrown is h in meters. This is a load of waffle, which basically means half the problem with exam questions is understanding them. So basically it means that we can work out the height based off the time. And this is a negative squared because it's going to, the height's going to decrease. Well, it's going to increase, but at a decreasing rate, if that makes sense. So it kind of gets higher and then it gets higher, but slower. Hopefully that makes sense. So we want to work out the values of t when the height of the ball above P is 5 meters. So I'll give you just like 20 seconds or something to read over that to make sure that it makes sense and see if you know what to do, and then I'll go through it. Okie doke. So all this is again, it's asking you to set up your own quadratic equation. So we've just got to look for these clues in the question. So we know that this here h is the height above P of the ball, and it's just said that the height above P is 5 meters. All that means is h is 5. It's saying solve for t when h is 5. That's all they're saying here. But they put it in a load of words to make sure that you can understand complicated questions. So what it's saying here is solve 5 equals 11t minus 5t squared. A lot of the quadratic questions look like this form. So they're about balls being thrown or bacteria multiplying. And it's because a lot of those can be modeled with a quadratic equation. That basically means that you can write what's happening in terms of a quadratic. And that's because they like the exam questions to be kind of more real life stuff, which makes sense. You can kind of see how we could use this in physics, and then it could apply to other areas of science, rather than just being useless stuff. So never get put off by big, scary, weird scenarios. So hopefully I've blabbed on for long enough that you can see that we're going to have to rearrange this to make it equal 0. So we're going to pop this 5t squared over to the other side to start with. We'll go nice and slowly. So we put that over to the other side. Just we like our t squared to be there, and we like it to be positive. And then we just have to take this 11t over to the other side as well. And we're going to pop it in the middle here. Because this is how we like our equations to look. T squared, t constant equals 0. And now, lovely stuff, we've got a quadratic equation that we can solve, because we know that we can solve things like this, as long as it factorizes, which I haven't checked, so hopefully it will. Who knows? If not, it will lead me nicely on to the next topic. So I won't dwell too long on this because we've done a lot of these, but we set up the brackets. We know that this is going to be 5t and t. We know that they're going to be a minus and a minus. And we know that our numbers are going to have to be 1 and 5. So at least we'll find out quickly if this doesn't factorize. Which it doesn't, does it? That's really helpful. That's really great. That means we can pretend I planned this. That leads us very nicely to completing the square, which is another method that you can use to solve equations when this doesn't work. If you can't factorize it, so the reason I could tell is because if you put 1 and 5, you get minus 2060. If you put 5 and 1, you get minus 10t. So we'll come back to this question. Don't worry, I haven't forgotten about it. But what I would like to cover now, we've got like 10 minutes before I'll take more questions. So I would like to cover completing the square. The reason that it's called completing the square is because we're trying to put it in a form of x plus something squared, and then you complete it by adding or subtracting whatever you need on the end. This will make sense in a moment. Some of you might have seen this before, some of you not, some of you might be confused. So hopefully I go at the right pace. So let's say we have something like this. X squared minus 8x plus 5. Now we can't factorize this. A quick bit of trial and error will tell you that. So we'll have to try something else. Now the completing the square format is really nice. Maybe in another lesson I'll cover, there are other things that you can do with it. So you can find the minimum point of a curve really nicely. So by completing the square, we know what the minimum point of this is. But again, that's not for today. Just letting you know why we do this. We're not just doing it for fun. So the completed the square form looks like this. X plus something, we'll call it A, all squared, plus something else that we'll call B. So we put it in this form. You know, something squared plus B. This looks like quite a nice form, and you'll see why in a moment actually that it helps us solve equations. So we can set this up a little bit. X something squared. Now, what will that something have to be? For this stage, we're going to just look at this minus 8x and decide. Well, when we multiply something out that's squared, let's say we're multiplying out x plus 2 squared, well, that's the same as x plus 2, x plus 2, which is x squared plus 2x plus 2x plus 4. We don't really care about these bits. The point that I'm trying to get at is that this is added twice. So to get minus 8x, we want this to be minus 4. Hopefully that makes sense, and I'll kind of prove to you that that works now. Because the next step that we have to do in completing the square is expanding this out. Because what all we need to do now is work out what we have to whack on the end to make it plus 5. So we'll check where we're at the moment by expanding it out. So we get x squared minus 4x minus 4x, so minus 8x, and then that minus 4 squared. So just in case you need to have a look at this, go for it. So x squared minus 4x minus 4x, and then minus 4 times minus 4 is plus 16. So that's where we're at the moment. And look how close we are already. We've got our x squared minus 8x. Brilliant. All we've got to worry about is making this 16 into a 5. And how do we make a 16 into a 5? Well, we minus 11. Minus 11. So that's all we're going to do is minus 11 from both sides. And this becomes x minus 4 squared, so this, and then we just take off that 11. So this is our completed the square form for this. Hopefully that makes sense, especially if you've never seen it before or are a bit out of practice with it. There's really only 2 steps to it. You choose what number goes in here, you expand, and you choose what number goes at the end. I say choose. There's only really one option, but work out. Now, this is super helpful for solving quadratic equations, and I'll show you why. So let's say that our question had been I'll do it to the side actually. Let's say that our question had been x squared minus 8x plus 5 equals 0. We want to factorize that. We can't. We've completed the square. x minus 4 all squared minus 11 equals 0. Now, we can't solve this like straight away without doing anything to it because we've got x's in 2 places. But now we've only got x in 1 place. And when we've only got x in 1 place, we can solve stuff in the normal algebraic way of just rearranging things. So we're going to add 11 to both sides. X minus 4 squared equals 11. Then we're going to square root. So square rooting a square just gives what you had. I worded that really poorly. If we had x squared and we square rooted it, we get x. So when we have x minus 4 squared and we square root it, we get x minus 4. You just knock off the squared. And that's equal to root 11. And then we just add 4 to both sides. And the convention is that we put the number first and then the surd second, so that's square root second. So x equals 4 plus or minus. Sorry, I should have written this here. When we square root something, it's plus or minus. Gosh, I spent so long saying it and then forget it myself. And that's because of the reason that I said before. For example, minus 11 squared is the same as 11 squared. So then you get 4 plus or minus root 11. And we have 2 solutions, as we expected. It's a quadratic, we were expecting 2 solutions. So we've got 4 plus root 11 and 4 minus root 11 are our 2 solutions here. So if we were to solve it, this is what we get. If you don't believe me, you can go away and put this into the quadratic formula. So that thing that we wrote out last time, minus b plus or minus the square root of b squared minus 4ac over 2a. Don't worry if what I said makes no sense. That's not the point of today. That's just a reminder for those who do know it. And if you whack everything in there, I promise you, you'll end up with this. So hopefully, yeah, that makes sense. And that's how simple completing the square is. And it puts it in this lovely form. So I've got 2 minutes before questions. So I'll hop back to this example to finish this. So this, we can't factorize. I'll put this, hopefully you can still see that. I know I've made that quite small. Oh no, we can't factorize. But we can complete the square. Now, I'm tempted to change this example because this is going to be horrible, and I'll tell you why. We haven't got on to advanced completing the square yet. Oh, exciting. That's just where we have bigger coefficients, again, of x or of t or whatever. And here we have a 5t squared. And that's going to make things a bit more confusing. So what I'm going to do is pretend that the question is slightly different and cheat a little bit. So we'll pretend that the question said that this was t squared minus 10t plus 5 equals 0. We'll pretend. Don't do this in an exam, but for the purposes of now, we can pretend that this is what it was. So we know that the first thing that we have to do is to set up our brackets. So we have something squared, t something squared. And if we remember, even if you can't remember exactly why, just remember that it's half of this, basically. T minus 5. And then as a kind of middle step, we have to work this out. T squared minus 10t. Without even expanding, we know it's going to be that, because that's why we chose these numbers in the first place. And then it'll be plus 25. Because that's minus 5 squared. And then how do we get from, so this is what this equals. How do we get from 25 to 5? We subtract 20. So that is our completed the square form. And oh look, we're in exactly the same situation that we were before. Wonderful stuff. We can play around with this. T minus 5 all squared equals 20. I've just added 20 to both sides. T minus 5 equals root 20. I've just square rooted both sides. And then t equals 5. Oh my gosh, plus or minus should go there. 5 plus or minus root 20. Now, something that I've spotted with this is that I'm not going to be able to prove the point that I wanted. Oh, okay, no, I will. Everything's fine. What I was going to say was sometimes you get a negative result and a negative time doesn't matter. But here, if we work this out, we'll get something like I'm just going to completely make up examples. These are not the answers, but 0.2 seconds and 9.8 seconds. And so that's saying work out the values when the height is 5 meters. So what that would mean is that it would go up, and in 0.2 seconds it's here, then it's up in the air for ages and ages and ages, and at 9.8 seconds it's also there. So just to visualize that and put that into some sort of context. I know I cheated because I changed the question, but that's just because it was too advanced for what we got onto today. So that's all of the teaching stuff. Yeah, do you have any questions?
Hey Molly, a few questions have come through. So someone wants to know why you subtracted 20 up at the top with the red.
Oh, here? Oh, okay, I see. So that's because, let me zoom into this. So what we're trying to do is make something of the form, basically with something squared and then add something onto the end. So we know that the something squared has to be this to give us the t squared and the 5t. And then what we add on the end determines the constant. So the reason is because we have, so I'll write it here. What we have at the moment with this thing squared is t squared minus 10t plus 25. And what we want is t squared minus 10t plus 5. So that's what we have by expanding that out, and that's what we want. Just by that's our question. So the question is, how do we get from here to here? Well, the t squared and the t's are the same, so it's just how do we get from 25 to 5? Well, we minus 20. So that basically means that what we want is this t squared minus 10t plus 25 minus 20. That gives us this. And then we know that this t squared minus 10t plus 25, it is what we've just done. It's t minus 5 squared. Hopefully that makes sense. It's basically because it's how you get from the constant that we have to the constant that we want. And how you do that is you subtract 20.
Cool. Another question that came through was, are we or can we use quadratic equations to find roots and turning points?
Yes. Okay, cool. I can briefly explain that for you. I'm going to do it with this example that we had here. So the way that we find roots is by factorizing. So let's leave this up here and do a new page for this. Roots of the equation just mean what you whack in to make it 0. So if we had one that was like, we'll go right back to one at the beginning, x squared minus 15 x plus 56 equals 0. I'm just going to do the factorization because we did do it at the beginning. It's going to be x minus 8, x minus 7. So x equals 7 and x equals 8. So that's just a really quick how we did that. So 7 and 8 are the roots. If you put 7 in here, you get 0. If you put 8 in here, you get 0. And that's where it crosses the x-axis. So basically, I did this briefly last time. We mark on 7 and 8. That's what our, that was bad. That was a bad drawing. That's what our curve looks like. That's a bit better. Going through these points here, 7 and 8, which are the roots of the equation, because that's where that equation equals 0, because that x-axis is 0. So that's about roots. Turning points, I'm going to explain it briefly. Do shout if you need more on it. But if we look here, let me get rid of that. So just looking at this. So let's say we have the equation x squared minus 8x plus 5. And the question is, what is the turning point? Now, first of all, to briefly explain this, in fact, I'm not going to draw the axes. This graph, because it's an x squared, looks like a smiley face. Whee. And the turning point is where it turns. It's this minimum point here. And we've put it in the form here, x minus 4 squared minus 11. So we want to know what the minimum that this can be is, basically. So hopefully this makes sense. So this is always quite hard to explain. You just kind of have to, I'll explain it and then try some yourself, think about it. What's the smallest that we can make a square? Well, it's going to be 0, because if we square -2, we get 4. If we square a positive number, you get a positive. If you square a negative number, you get a positive. So how on earth can we get a negative? Well, we can't. So the smallest thing that a square number can be is 0. And that's the reason that I'm doing that is because we're looking for a minimum point. We want to know when this is the smallest that it can possibly be, because we know it's got to stop at some point and start going back up. And this square is going to equal 0 when x equals 4. Right? It's kind of like how we did it before. So when x is 4, that becomes 0. If x is anything else, this square isn't 0, and therefore it's bigger than our minimum because it's positive. Right? So any time that this x isn't, so this is where x is 4, and anything above that, if x is bigger than that, it starts going up here. If x is smaller than that, it starts going up here. So x equals 4 is as small as we can make this. And then to find our y value, well, what we mean by this is actually y equals all of this is the equation. So when this bit is 0, y is just -11. So that's, to make you understand it, a quick way is the opposite of this and this. So the x value is 4, the y value is -11. And just to show you that on a graph, if we put it around this curve here, x is 4, y is -11, it looks a bit like this. So the x value is 4, the y value is -11. So if you're asked to sketch a curve, you can sketch it just based off the minimum point. I hope that makes sense. That was a very rushed kind of explanation. But yeah, I hope that makes sense.
Okay, I think we have time for 2 more questions. We have a question that asks, would you still use completing the square if you have an odd coefficient of x for the middle number?
Yes, good question. Yes, you would. It's just, this is why I avoided it before, because it's a bit more confusing, but I'll very briefly explain it. But don't worry. So I remember from yesterday, there was a mix of foundation and year 8s and stuff to higher level. So don't worry if you don't understand this. Yes, you would still use it. You just get a fraction. So let's say we have x squared plus 3x minus 6 or something. Yes, we can still use completing the square because we can't factorize that. I hope we can't. And so we'll have the x. And what we're going to add here is half of this. So 3/2. We could call it 1.5, but fractions are your friend. Decimals are difficult because they can be recurring, and we understand fractions a lot more. I promise you fractions are nicer. And then we can expand this out in the same way. So we get x squared plus 3x plus 9/4. To square a fraction, you square the top and the bottom. And then we just have to work out how we want to get from here to here. And that's basically by doing -6 minus 9/4. I won't do the whole working out of it because it's fractions and that's not what today is about. But -6 minus 9/4 is 4 minus 9/4. I think minus 33/4. We hope. It doesn't matter. I mean, it's not really about that. But then we end up with squared minus 33/4. So the answer to your question is yes, you can still use it. You just get fractions.
Cool. And then another question was, is this from an exam board? Is it a technique?
Okay. So I'm not 100% sure what you mean. It might be that you're asking about the question that I did, maybe. That question would be from an exam board. I just don't know what. I got it from a resource. So it's just a kind of generic one. Is this a technique, completing the square? Yes, completing the square will be on every specification, I would have thought.
Cool. And then we've had some more general questions, which I can probably jump in to answer. So quite a few people have asked, are these videos daily? And they have also raised that they might have missed the session yesterday. So to answer both those questions, the videos being daily, so we do have a schedule for these live group tutorial sessions, which we'll be sharing very shortly, but there's a link to a survey which I'm sharing. Okay, so quite a few people have asked some general questions, which I'll try and answer now. So there are two main questions that people have asked. One is around, are these sessions going to be daily? And another is around where they can access videos of past sessions. So I'll answer both of those now. So are these sessions going to be daily? So we do have a webinar schedule, which we'll be sharing very shortly. But I also have a link to a survey, which I've shared now in the chat. So if you fill out this survey, then you can help us learn more about when you'd like tutorials and how often you'd like tutorials, and then hopefully we can plan these sessions around your preferences. The second question around how you can access tutorials if you miss them. So all of these tutorials are recorded and they will be hosted on YouTube, but we will be providing the links to the specific sessions in an email that will go out. So don't worry if you've missed either today's session if you've missed yesterday's session and you'd like to watch today's session back again, then you'll be able to access the links for those. Other questions coming through are, will there be different subjects? Yes, we do have plans for different subjects. So some people have asked, will there be chemistry and biology lessons? Yes, we do have plans for different subjects. But as I say, the more of you that fill in the survey that I've shared in this chat, then the more clear we can be as to what subjects we want to offer, and then also within those specific subjects, what topics you'd like to see as well. I think those are all the questions that everyone's had. Looking through, I think we've covered everything. So yeah, I guess the last thing to say is thank you for joining again. And we'll be able to give you a better idea of what live group tutorials we have coming up once people complete the survey. Thank you, Molly, and thanks everyone, and hopefully see you soon. Bye.